Okay, we are going to spend a little bit of time today looking at some equations of lines. There are kind of three formulas that we use for equations of lines. One of them is point-slope form, which would be this one on the left right here, okay? In order to use that form, what you need to know is you need to know the slope, and you need to know one specific point on a graph.
Brian Moore, please come to the office. Brian Moore.
Excuse me. Sorry about that.
Please come to the office.
Then there's slope-intercept form, and slope-intercept form is probably the one you're most familiar with, and that would be in y equals mx plus b form. And in order to use that one, you need to know the m, which is the slope, and the b, which is the y-intercept. So in both of these equations, we're going to kind of look at what this means, okay? Both of these equations, m is slope, okay? And remember that slope is rise over run, vertical change over horizontal change, or change in y over change in x. I can't even remember what all the things, whatever other things you called it, but that would be one, okay? M is the slope. And that happens here, and that happens here. I want you to notice, okay? B is the y-intercept. It's where it crosses the y-axis. So on a graph, the y-intercept would be like this point right here. It's where it crosses the y-axis. They always have the coordinate 0, b on a graph, just so you know. Your x value is 0, your y value is b. Okay? Then notice this equation right here has an x and a y in it, and this equation has an x and a y in it. And that, just the generic xy means it represents any coordinate on the graph. Okay, and then you will also see that this one has an x1 and a y1 in it, and that is a specific coordinate on the graph. Okay, so those are two equations that we use most often. Our point-slope form, you need to know a point and a slope, and then y-intercept form, which in order to use that, or the most useful time to use that, is when you have the slope and the y-intercept. Then there's also what is called standard form, and standard form is an equation that is in this form right here. It has the x and the y both on the left side of the equation with the constant on the right side. And there are some rules to having things in standard form. First of all, the GCF must be 1. You can't be able to reduce it. So in this example right here, you can see if I have 2x plus 4y equals 8, I can divide each one of those by 2 to reduce it, which means I have to do that, and I can't leave it as 2x plus 4y equals 8, because then it's not in true standard form. Also, the leading coefficient, which ends up being the number in front of your x term, has to be positive. So in this example right here, you have a -3 in front of your x, and that's not in true standard form either. And so what you would do is you would multiply this entire equation by -1 and switch all the signs on it until it became in this form, which has a positive leading coefficient now, a +3 right here, which means that it is in true standard form. And then lastly, your standard form equation also can't have any fractions or decimals in it. So if it has things like 1/2 x or 0.5x or whatever anywhere in the equation, it doesn't have to just be with the x. You have to get rid of those also. And I'll show you how to do that when we do a problem here in a minute, okay? So those are just kind of some quick rules to go over.